In California, some utilities find that up to 75% of HVAC contractors who study it struggle with field commissioning and are unable to adequately perform load calculations. In 2010, the University of California, Berkeley cited challenges with installation and maintenance in California's HVAC industry, resulting in significant losses of home energy and energy savings. The California Energy Commission finds that total energy savings from higher quality HVAC installation in the residential and small commercial markets could exceed 1.2 gigawatt hours by 2020. This savings represents roughly 2 combined cycle gas-fired power plants, each able to generate 500 megawatts of power.
Nobody's on the same page. And it's kind of interesting because we do have something that's called the laws of physics where everything functions properly. If everybody was on the same page and truly understood what the laws of physics, we wouldn't have these problems.
The levels and the skills and the knowledge and the abilities of these new individuals for this new workforce varies quite significantly from how we've trained individuals in the past.
You know what? Homeowners, they're seeking for professionals. They know they got some kind of a problem. They get pain, literally. Whether it's in the form of high utility bills or they're uncomfortable, whatever it is, right? They have this pain and they don't get the answers. What needs to happen here is we need to get a baseline of understanding to train up the contractors, the installers, the maintenance individuals, the service technicians. You can truly go out and build a system and commission it to prove exactly the way it is. Now, if the consumer gets energy efficiency, they're going to get comfort. They're going to get health and safety issues.
We can improve building performance and the building performance industry.
There's a large body of evidence that's been gathered over the last 30 to 40 years about building science, energy consumption, energy usage, what's the cheapest way to save a lot of energy and that kind of thing.
There's so much to learn. There's so many different avenues and factors that one has to kind of overlay on this industry.
We found that people need to be prepared for this. They need some science background, they need some basic math, maybe algebra up to 10th grade or pre-algebra at least.
In home performance, all of the trades are intertwined. We cannot do a good home performance job without the insulator, without the drywaller, without the electrician, without the plumber. All of these trades have to understand the direction we're trying to head.
We believe that learn as you earn or blended learning models that combine theory with practice are the best vehicles for preparing a thoroughly trained 21st century building workforce.
Learn as you earn training models, I think, are very important, we found in our experience, because it's important that somebody obviously understand what they're learning from a conceptual standpoint in the classroom, but at some point they also need to be able to apply what they've learned in practice or in the field.
We've learned all this theory, and the theory, just in your head knowledge, just can just go out the window, but to apply knowledge, that's where the power is.
We've found in our work that it's best when you have direct input from private industry, direct input from labor, direct input from management on what the work is going to entail.
We need a centralized, uniform training process with mentors in the field to make sure these guys really know exactly what's going on.
The National Renewable Energy Laboratory, in cooperation with the American National Standards Institute and the Interstate Renewable Energy Council, have set higher standards for the skills needed by the building performance workforce.
Well, ANSI and IREC are two highly recognized organizations, both nationally and internationally. They develop standards through a very rigorous process, and then if you're going to comply with those standards, you have to go through a rigorous process to show them that you have in fact complied.
People need to understand what kinds of skills and credentials they're going to receive by virtue of the type of training that they're getting ready to invest significant amounts of time and money into.
The ANSI-IREC accreditation process, the certificate training programs specifically, are built to be able to reinforce the installer retrofit technician, to reinforce the energy auditor / assessor. Who is that crew leader and what do they need to know?
Standardized training is important for a clean energy workforce because it establishes the rules of the road for training entities, for government institutions, for students, and for employers. It's really important that we understand what we're training to.
To me, this is the 21st century construction industry. If you want me to learn, then you've got to give me an avenue to learn as I earn.
The bar is higher, but there's a place in 21st century building for those with the commitment and desire to be among the best.
Every one of us out here in this field have a resource to bring to the table. And part of the problem is we don't even know how to connect to each other. So we don't have a very good network right now. And if we can build those partnerships and take those resources and align ourselves, we are going to have a really solid industry. And I believe everything is out there. We just have to learn how to connect the dots.
Join CalCERTS and the Building Performance Center Incorporated in forming a national network of partners dedicated to developing experiential learning opportunities for the 21st century building workforce.